This webcast talks about two additional problems using the friction force. So I'm at problem number 5. So here we're talking about someone who is pushing a book against a wall, and friction is keeping the book from sliding down the wall. Okay, and so let's do a force diagram for the book. So they give me the mass of the book so I can find its weight, and that points down to the center of the earth. And so half a kilogram times 9.8, the weight of the book is 4.9 newtons. The applied force, as shown in the diagram, is to the right. So this is an applied force on the book by a person, and that's 15 newtons. So the wall is supporting the book, right? Here's where the wall and the book are pressed against each other. In this case, the normal force is actually perpendicular to the wall, right? The normal force is always perpendicular to the two surfaces that touch. And so the normal force on the book by the wall, it's going to be balancing the applied force here, because the book is not moving to the right or the left, right? It's just sitting there touching the wall. So I know the normal force here is 15 newtons. The reason that the book doesn't slide downward is because there's a friction force on the book by the wall. Okay. So it says, what is the minimum coefficient of friction to keep the book from sliding? So if there's no sliding, we know that the net force in the vertical direction is going to be 0. And that would be the friction force minus the gravitational force. So in other words, the friction force would have to at least equal the gravitational force. And the friction force would be the coefficient of static friction, because we're talking about not sliding, times the normal force on the book. And so the coefficient of static friction, let's see, our normal force here is the 15 newtons. The gravitational force is 4.9. So that coefficient of static friction would have to be that ratio, 4.9 divided by 15, which is 0.327. And one last problem here is James in number 6. He's pushing a 50 kilogram crate with 320 newtons of force. And they're giving us both the static coefficient of friction and the kinetic. And so we're going to have to make a decision of, is he pushing hard enough for the crate to start sliding? So let's just do a little force diagram for the crate. The weight of the crate, since it has a mass of 50 kilograms, is 50 times 9.8, 490 newtons. James is applying a force of 320 newtons. In this case, the floor is supporting the crate. The crate's not moving up and down, and so the normal force and the gravitational force are balancing. So I know the normal force is 490 newtons. And there's a friction force I don't know yet if it's static or kinetic because I haven't decided if the crate is moving or not, but there's a friction force on the crate by the floor. Okay, so first I want to use static friction to see if the crate slides or not. Okay, so that's my first step. So the static friction would be, the maximum static friction would be the coefficient of static friction times the normal force, which would be 0.6 times 490. Which is 294 newtons. So I want to, the net force, or actually, you know what, I can just say, since the applied force is greater than the maximum static friction force, the crate will slide, right? He's pushing with enough force to overcome the static friction. So now, because the crate is sliding, you know, I've been able to decide that, I'm going to use kinetic friction to find the acceleration. Okay, so the kinetic friction is the kinetic coefficient times the normal force, which is 0.35 times 490. (171.5 newtons). I find the net force, which is the applied force, minus the kinetic friction. So the net force is 148.5 newtons. And so now that I have the net force, I can find the acceleration. Actually, so the acceleration would be the net force divided by the mass of the crate, which is 148.5 newtons divided by 50 kilograms, which would be 2.97 meters per second squared. Okay, so just recapping that strategy. When a problem gives you both the static and kinetic coefficients of friction and asks you, will it slide? The first thing you have to do is to use the, you want to use the static friction to see if the crate slides. If it doesn't slide, well, fine. The problem is over. Or if it asks you, you know, what's the minimum force to make the cart slide, anything bigger than that maximum static friction would make it slide. But we decided in this case, yes, the crate was sliding. So then we had to use kinetic friction to find the acceleration. So we went back, calculated the kinetic friction force, and used that to find the net force on the crate, and then to find the acceleration.